Hello. Now we're going to look at finding the number of solutions to a system of equations by graphing. So again, I want you to remember that when you're solving a system of linear equations, or any system of equations, because they're just not linear, contained in a word problem, when you're graphing, anything like that, you're still looking for what point or ordered pair makes both equations true. So when we graph it, what we're looking for is if the lines are parallel, meaning they run along each other like train tracks, they're never going to cross. So that means there's no solution. I'm front loading a word for you here. It's inconsistent. We use this word in Algebra 2 a lot. Inconsistent just means basically they don't jive, or they don't agree. That's inconsistent. You can think of it that way. That's not technically what the word means, but you can certainly think of it this way. Also, if the lines do intersect or cross at one point, this is what we call one solution, or consistent because they agree, independent because it's two different lines. Okay. Third is if the lines are exactly the same, then there's an infinite number of solutions because every point on both lines makes the equation true. So here's our process. We're going to graph the first line, then graph the second line, and then decide if they have solution or not. So we have y is equal to x minus 2. So the first thing that we're going to do, because this is in slope-intercept form, we're going to go ahead and graph the y-intercept, which is -2. Then we know our slope here is basically 1 up and 1 over. And we know that because there's an imaginary 1 in front of the x, and we know that we have to have rise, which is the 1, over run. So here we have this line. Now you could take it out further if you wanted to. And then we're going to graph the second line. We've got the same thing. So -2 up 1 over 1. It's exactly the same line. So because they're exactly the same line, we would say that we have an infinite number of solutions. Now if we look at this one, this is graph these equations. How many solutions do they have? Well, the first line, we are going to start at 3. And notice it's a negative slope, so we know it's going to go, as we read the graph, it's going to go down from left to right. So I'm going to go down 1 and to the right 2, or some of you may choose to go up 1 and to the left 2. Either way is fine. So I've got this line. And wouldn't you know, I did not bring a ruler home from school. My math teacher doesn't have a ruler. This one right here. Okay. So now let's look at the next line. If you notice, I know what you're saying to me, Ms. Clark, it's exactly the same, and you would be right. So again, these are exactly the same. So we would have infinite solutions. On this one, we've got graph these equations, how many solutions. So all of these will be the same. But what I want you to notice here is that this first equation is in standard form. Well, standard form is all well and good if we want to use the x-intercepts, right? So I could say x plus y is equal to 2, and I could cover up y. So x would be equal to 2, and that means that one of my intercepts would be 2, 0. And then I could cover up x and say y is equal to 2, so my other ordered pair would be 0, 2. That's one way to do it. The other way to do it is, okay, well, I've got x plus y equals 2. And remember I said, or you could just put it in slope-intercept form. So I could subtract x here from both sides of the equation. And I could have y is equal to negative x plus 2. Now, I'm going to go ahead and use this because I want you to see that when you use standard form and you look at the intercept, the line is going to be exactly the same. So I've got y is equal to negative x plus 2. So I'm going to go ahead and put my first point at 2. And then I know I go down 1 and to the right, down 1 and to the right. As I'm going to grab something to make this line straight. It's not the most professional, but we're problem solvers, so that's what we're going to do. Oh, that's so much better. And then my second line is already in slope-intercept form. So I've got negative 5. And it's also going down 1 and to the right 1. Down 1 and to the right 1. So these lines are parallel. Now remember what I told you? That if I use the cover-up method, that I would be able to do this as well. Well, look, I've got a point at 2, 0, and I've got a point at 0, 2. So those of you who want to use the cover-up method, it's not going to mess you up in the least. You can go ahead and do that. It's just as well as using the method where we go ahead and solve for y to end up with slope-intercept form. So in this case, we've got no solution. We've moved on to the next graph that we're going to do. What I'd like to do here is I'd like to go ahead and solve for y. So I know that by solving for y, I need to put 4x on the other side of the equal sign as well as 12 on the other side of the equal sign. So looking at the signs in front of both of them, I know they're both positive. So I'm going to subtract 4x and subtract 12, and I'm going to do that on the other side of the equal sign as well. And the reason why I'm doing that is, one, to save room, so that I can just kind of get two things done at one time. So I want to get y alone, so I divide all terms by 12. That gives me y is equal to, well, 12 doesn't divide into 4, but we know that we can reduce both terms by 4 because 4 is a factor of 4 and 4 is a factor of 12. So 4 goes into negative 4, negative 1 times, and 4 goes into 12, 3. So that gives me negative 1/3 x. And then negative 12 divided by 12 is negative 1. So that's one line that we are going to be able to graph. And then the other line here is going to be, let's see, we've got 3x plus 6y plus 12 is equal to 0. I'm going to do the same thing. I want y alone. So I'm going to subtract 3x and 12 from both sides of the equation. I'm going to divide every term by 6. And that leaves me with y is equal to negative 1/2 x minus 2. So now I've got two lines that I can go ahead and graph. The first line, I'm going to start at negative 1, and I'm going to go down 1 and to the right 3. Down 1 and to the right 3. I could switch these around and make this one positive, so I go up 1, which means that this 3 becomes negative, and to the left 3, and that gives me this line. I'm going to go ahead and make a note of which one this is. Then the other one what I have is at -2. And we're going to go down 1 and to the right 2, or up 1 and to the right 2. And so here we see that the 2 lines cross, so we have one solution. Now maybe some of you are wondering if we could have done the cover-up method here. Yes, we could have, but you just have to remember if you're going to use the cover-up method, then the constant has to be on one side by itself. So it has to be AX plus BY equals C in order to use the cover-up method like it is here. So that's also another way that you could have done it. If you have any questions at all, please let me know. Goodbye.